It's going to be really easy to make groups today. Okay. So we only have a couple things to finish from 7.4. 7.4, 7.3 was about ratio proportion. And they made nothing but sense for 7.4 to be percentages. Because all percentages are fractions that we've sort of converted into percentages, right? We talked last time about how to convert from fraction to decimal to percent and vice versa. Yes? Yes. Okay. So the only thing we have left to talk about directly are a couple little tiny things. One thing you should know that's kind of related to a decimal equivalent we already talked about is what is 25% as a fraction? Yeah, 25% of something is 1/4 of something, yes? So if I said something like 25% of 484, could you do that in your head? Yeah, you could. Give yourself more credit. What does 25% mean? As a fraction, 1/4. What does 1/4 mean? It means take whatever it is and divide it by 4. Or you could say cut it in half and cut it in half again. That's another kind of method. So when I say 25% of something, I can automatically think divided by 4. All right, what's 4 divided by 4? 8 divided by 4. 4 divided by 4. So 121. Done. You guys with me? You guys with me? Now obviously, if it isn't exactly 25%, you could round it to 25 and do an estimate. But if it is 25%, that is equivalent to divide by 4. Okay, you all came in here knowing that, essentially, just maybe never thought about it directly. You know 25% is 1/4 of something. Okay. What about this exceptionally ugly looking poor little dude here? $33 1/3% of 9,006. What's your problem, Jeff? So real quick. Sorry. I was reading your minds. Does anyone happen to know what 33 1/3%, what fraction it's equivalent to? And you all know this, you just don't know if you know it. What is 0.3333 forever as a fraction? 1/3, yes? Okay, now what is 0.3333 forever? It's 1/3. So what is 0.333 forever as a percent? How do you change from decimal to percent? Yeah, 33 point. It's not 33%, it's 33 point. Why does it look like it's 3? 3, yes? Yes? But would we say 0.3333 is? So this is 33 1/3%. So when I say what is 33 1/3% of something, that just like 25% is equivalent to divide by 4, 33 1/3% is equivalent to divide by 3. You guys follow? All 33 1/3 is a bunch of 3's forever, which is what 1/3 is. Yes? So what's the answer? What's 33 1/3% of 9,006? 3,002. Yeah, 3,002. Yes? Maybe? Yes? No?
Yes.
Okay. Okay. And of course you have 75%. Does anyone know what 75% is? It's a little bit worse, but it's not too terrible. 3/4 of something, yes. Okay. So you have these fractional equivalents for decimals for percentages, because percentages are just decimals, and we had fraction equivalents for decimals. Maybe? Okay, I'll look at this. Then, let me just shit all over social media for a minute. You whatever social media site you go to. You occasionally get, for example, dumbass PEMDAS questions. Alright, I don't know, you guys probably just go by those, because they're not in your feed, because unlike a math person, you're not necessarily getting that shit, but every now and again I'll see there's a whole bunch of comments where they all disagree with each other, and I just come in and I say, y'all need math, and then I just leave. So what I see sometimes, that's why you're writing so big, is somebody will go, holy shit, why did they never tell me this trick? 72% of 50 is the same thing as 50% of 72. And why is that nice? Why is 50% of 72 nice? I'll talk about why that's true in a minute. Has anyone ever heard of this trick? All right, I'll show you why it works, but just tell me, why is that nice? What's 50% of 72? That just means cut it in half. And what's half of 72? 36. This is true. This is a true thing. And people will go, what's wrong with the education system? Why didn't they tell me this? And I'll say, they did tell me this, person. We know about compensation, yes. When I say compensation mathematically, what do I mean? Can somebody give me an example or explain to me what I mean? What is compensation in mathematics? What does that apply to? It's come up a few times in this class. Can somebody come up with either an example or an explanation about what compensation is? Here, I'll help. What about if I had 5 times 48? How could I use compensation to help me? No, that's equal additions. And I can't do that within a multiplication problem. You're fine. Yeah. Into what specifically? What does 5 need? What factors does 5 need to become a number that's really nice to multiply by? What number is really nice to multiply by? 1, great. What other number? 10, isn't it nice to multiply by 10? 10 times 7, you stick a 0 on it, you're done, right? So what does 5 need to become 10? What factor? 2. Does 48 have a factor of 2? So I compensate. I have 48 pay 5, a factor of 2. So like Lily said, you break up 48. How? Anybody. It's not just 11. It's 24.
I'm so sorry. I didn't know you were asking me.
Yeah, 2 times 24, yes.
4.
And then 5 times 2 is 10. And 10 times 24 is 240. So you can kind of, real quick, if I ever have to multiply by 5, divide this in by 2 and add a 0 on the end. That's how you multiply by 5. Why? Because of this. You guys see that? I divide this by 2 because I have to steal a factor of 2, and then I put a 0 on the end because then I would be multiplying by 10. Do you guys see that? So a lot of times I'll see people say, oh my God, I never told you this. All you have to do is this. And I'm like, they told you that. You just didn't listen. So, how does this apply to this problem here? So 72% of 50. Can somebody, how do I write 72% as a fraction? Yeah, 72 over 100. What does of mean? Multiplication. So here's the weird compensation. Now, I already showed you the shortcut. This is the reason why the shortcut works. I'm going to use compensation, but in a really weird way. 72 over 100 is 72 times 100. No, 72 times 100. Yes. Are you guys cool with that? 72 divided by 100 is 72 times 1 over 100. Yes? And then I could put these together. which is 72 times 50%, 0.5, which is 50% of 72. That's the trick, yes? That's why the trick works. You're using compensation. You're taking the divided by 100 off of one thing and putting it on the other thing. Math don't give a shit. Math is like, you just gotta divide by 100 somewhere. So the little trick is, I'm gonna divide by 100 in a better place. What's up? What?
So you just so you said you have to just divide by 100 in some places, so you just moved it?
Yeah, so it was 72 divided by 100. I took the divided by 100 and I put it on the 50. And now this is 50% of 72.
And the one's just gone.
Huh?
And the one is just gone.
Well, I mean, 50 times 1 is 50 over 100. Yes. Is that all right? Is that all right? Okay. Because the one little thing I'm not showing, I mean, like this, yes, and like this, yes. So when I multiply these together, that's where this comes from. Okay. So it's just compensation. People treat it like it's a percentage trick. It's just compensation. And that's a general thing that you're taught. When you're younger, people just forget about it. Let me stop for a minute. Oh. Ba-ba. Oh, that's funny. So here, what if I wanted to do 160% of 25? Can somebody use the trick that we just went over to help me rewrite that in a better way? I gotta take 160% of 25. And I have to do it by hand because I have an evil teacher that said I couldn't use a calculator on this. Can you use the trick to rewrite this? I mean, the explanation about why the trick works uses compensation and all this kind of crap, but what's the trick actually end up looking like? You took the percentage off of one piece. I need you guys with me. So, ain't no way in hell I would just say, take the percentage and put it on the other guy without explaining why. So here's the why it works. But what's the shortcut? Take the percentage off of one number, put it on the other one. What is really going on? I took the divided by 100 off of one number and I put it on the other one, yes? So how can I rewrite this then? Instead of 160% of 25, 25% of 160. And why is that easy? Because 25% is equivalent to 1/4. And what's 160 divided by 4? 40. Yes. Cool. So you have the idea behind a trick, and then you have the trick, right? So now you could do that wherever in the universe you want to, because it's founded on sound mathematics. By the way, why does this answer make sense looking at the original problem? What would 100% of 25 be? 25. So 160% of 25 should be more than 25, yes? All right, let me push my luck. What would 150% of 25? It would be 25 plus half of 25. Yes? You with me? Half of 25 is about 12 and a half, so that would be about 37 and a half. So 160% of 25 should be a little more than that, and that's why the answer actually makes sense. Okay, maybe. I'm not saying you have to do what I just did in your head. I'm saying that's a way to kind of see, does it make sense, this answer? What would 200% of 25 be? You could do it. 100% of 25 is 25. What's 200% of 25? 50. Yes? Okay, so 160 should be between 25 and 50. 40 makes sense. Can we stop for a minute? Now, that's pretty much section 7 and 4. So you just gotta get in that homework and try it out. See where things get tricky. So, this is gonna seem silly, but I love this section. You're gonna see things you haven't thought to look at them this way. We're finally admitting that negative numbers exist. Does anyone know what we call the whole numbers? This set of things when we take the whole numbers and we add their negatives. What do we call that set of numbers? So if I take 0, 1, 2, 3, and then I add in -1, -2, -3, what is that set called? Does anyone know? I'll tell you what it starts with. It starts with the letter I. Starts with the letter I. Integers. What is it? Integers, yes. So if I have this set here, if I got all the negative numbers and all the negative whole numbers, all the positive whole numbers, and 0, I get the integers. Now, believe it or not, I have in the past, we used to teach a course here called Math 88. In that course, I would teach students, we would start with basically like, what's 2 minus 5? Yes?
Hi.
And so it's a trippy little idea. I don't know if integers offends people, but. So if I'm doing 2 minus 5, what way do you guys do that? How do you do that problem, 2 minus 5? Do you remember that? No, I guess I didn't. Shoot. I show a video to people and it kind of goes over the history of freaky numbers. And it gets into like imaginary numbers, which is a little bit beyond our elementary students, so we're not going to do that in here. But when negative numbers were first thought of, they were thought to be imaginary. If I have 1 apple and you take 2 apples away from me, what? Right? Do you have a negative apple now? You walk around with a little apple black hole? Do you guys kind of follow? So back in the day, they thought negative numbers did not exist. So 2 minus 5 to them would mean nothing. Unfortunately, nowadays, we know all too well, like our banks know, negative numbers exist. And when I was a college student, they would remind me, oh yeah, we know negative numbers. Looks like you have negative money. We're gonna charge you because of that. I'm like, what? Sorry. That was an exciting time for young Jeff. Take money I don't have. Yay. So, 2 minus 5, does anyone have a method you use to do this? Is your method? No. What's your method? Can somebody guess?
Can you swap them and then that'll tell you what the negative would be?
So you could do 5 minus 2, and then the answer is just negative that. Yes. Does anyone use that method? Cool. Does anyone know why that method works? Because that's not the problem, is it? Yes.
Because it's like you're moving on, like if you have a number line, you're moving one way, but you're just moving backwards. So it's like you're moving the same.
Okay. So the distance that the subtraction represents, you're just kind of putting in a different place. Okay. That's effectively what you said. I'm sorry.
No, I think so. Yeah.
Yeah, that is effectively what you said. Okay. Which is perfect. Which is perfect. There's a kind of a mathematical way to look at this. Believe it or not, this math problem. If I take 2 minus 5 and I factor a negative out, the negative 5 becomes positive and the 2 becomes negative. So that's exactly what we did, yes? We did 5 minus 2 and then we made the answer negative. So when I was teaching Math 88, I would teach them stuff like money. If I have $2 and I owe you 5, I could pay you off only so much. How much do I still owe you? If I have $2 and I owe you 5, I give you what I got. How much do I still owe you? 3. So a lot of people just they understand that completely because they think money all day, right? Or if I'm 2 feet up above the ground and I dig 5 feet down, I end up 3 feet below the ground. That's another kind of physical way to think about it. The most straightforward way to think about it is if I'm combining 2 numbers, I have a 2 and I have a -5. If I'm combining 2 numbers and they're different signs, I subtract them and put the sign of the bigger one back on. 5 minus 2 is 3, put the bigger sign back on. That to me is the most straightforward way to think about it. Okay. So obviously, a lot of our discussion today is going to be above the heads of people who have never done this before. So not surprisingly, we're going to work with manipulatives to explain this physically. Yes? Blah, 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 blah. Oh, good. So if I use chips, let me bust them out here. And unfortunately, we don't have black chips. The book talks about black chips. I've only got blue and red. So the blue is going to represent negative. No, Jeff. Positive. And the red represents negative. So if I wanted to do, let's start off easier. If I wanted to do, believe it or not, 2 minus 5 we have to build up to. 2 minus 5 is not an easy one to do physically with these chips. If I wanted to do, let's start off really nice. 5 minus 3. What's up? Oh, I need more of these. What number does this represent? 5. 5 minus 3 is physically telling me if I had 5 positives, I want to take 3 of them away. Yes? So students will latch onto this immediately. It's like they had 5 boys. Mama comes over and says, you can only play with, I want you to take 3 of those, put them away. I don't want so many toys now. So they know that means 2. So here, this is literally just the takeaway method. Take 3 away and you get 2 left. That's crazy. Things get more interesting when I want to do something like this. What if I want to do 1 minus 3? Why is that physically difficult to do? I mean, it's really immediately obvious. You got 1 and you got to take 3 away. This is the way that the ancients thought. Well, this doesn't make me ancients. The way that people back in the day thought. This is impossible. You got 1 apple. Hey, you can take 3 away. Right? You guys are all with me on the weirdness. So when a little student is first taught about this, and then we give them this problem, they're like, what the hell?
What the hell?
So here's the way around this. What we realize is, what does this represent by itself? What does this represent?
0.
Yes, -1 plus 1, right? There's a really good movie called Stand and Deliver about a math teacher trying to work with a group of students who start in like pre-algebra and he takes them to calculus. And there's this one scene where he's saying, fill in the hole, fill in the hole. And it's because if you have a 1 foot hole and you put 1 foot worth of dirt in it, you're back to 0. You filled in the hole, yes? So if I have -1 and I have 1, so if I owe somebody $1 and I find $1, I'm out of debt. I'm back to 0. Yes, I'm back to neutral. So if I know this pairing, this together actually represents 0. And I also know what's special about the number 0 in terms of addition. Keeps the number same. In fact, we call it the what? Do you remember? 0, we call it something. It maintains something. Identity. We call it the additive identity. So we stop for a minute. in terms of the red and blue chips, one red and one blue chip is physically a way to represent 0. And I can add 0 anywhere and not change the problem, correct? Okay. So, can somebody just explain to me in words what the immediate physical problem is here? I don't think anybody said it, but can somebody just tell me physically why this is a weird problem?
You only have one to take away.
And somebody's asking me to take 3, and I'm like, so understanding what we just said about 0, I can add 0 to anything in the universe, and I haven't done anything, I haven't changed it at all. And my problem is, I don't have 3 blue chips. I need at least 3 blue chips so I can take 3 away, yes? So how do I accomplish that? What can I give myself that will not change the problem? What can I add to this and it won't change? 0. And how do you represent 0? One red, one blue. So I just added 0. Yes? Do I have enough blue chips yet? No. Let me add 0 again, right? I desperately want you guys with me because I'm sorry. I am such a geek. I'm so geeky. I have friends that are like, how can you teach? Because I'm not really teaching you guys this. If I said what's 1 minus 3, you could do it. I know you could do it. What I'm teaching you is how to show other people what the idea is, correct? So they always ask me, how do you teach that class where you do 1 minus 1? I'm like, because it's fascinating as hell, that's why. This is cool shit, this is trippy. I have no idea if you've ever thought about anything like this before. 1 minus 3 physically does not make sense. But now I've made the physical reality make more sense. Can I take 3 away now? Yeah. So when I say take away 3, that means take away 3 positives. Yes? And what am I left with? Sorry? What is it? -2, which we know is the answer. Yes? That's cool. I know you guys knew the answer was -2, but it's kind of nifty to see it come out physically. Is that okay? You guys are like, calm down, man. It's numbers and chips. Okay. So, things get really nifty when we do stuff like, get out of here. What about 2 minus -3? Now, I know you guys probably know how to do that computational. What does minus and negative become? Plus. So we already know the answer should be 5. So whatever we are about to do, the answer better be freaking 5. Yes? Or else we all leave. Okay. You could have already left, I guess, Spencer. I'm glad you stayed. How do I get this problem started? Using the manipulatives. What do I give myself?
2 blue.
Yeah, I gotta start with 2 blues. So it says you have 2 blues, and I want you to take away. Now, what is it that this wants me to take away? Yes, mathematically it wants me to take away -3. How would I represent -3 with the chips? No. Not what do I give myself. Just how would I represent -3?
Oh, 3 reds.
3 reds. You with me?
Yeah.
So this wants me to take away 3 reds. Do I have any reds? But now we know what to do. So I really want you to pay attention to this. You've got to kind of divorce yourself from, okay, minus and negative is plus. We haven't proven that yet. We haven't shown that yet. We're just trying to get students to connect to this on a physical level, and then we can start getting some more details. Yes? And that's what parents don't understand. That's what some of you guys probably sometimes don't understand. I don't blame you. Like, why don't you just tell them how it works? Because we want them to connect to it. And then we can talk about weird little math details, but first we want to start physical. So I have to give myself what? What do I need to show up? 3, well, I need 3 zeros so I can make 3 reds show up. So I give myself, yeah, that's fine, Jeff. 1, 2, 3. And then I can do what? Take away negative 3. And what's the answer? Physically, we got the answer. Are you guys with me? It's almost like I'm like, be a little excited about that. It's really cool. Because then the next level, we've done this many times in this class. The next level would be, a minus, when you subtract a negative, it becomes a plus. And we've seen that physically, so they'll buy into it more. It'll make more sense. Okay. Oh, am I to a good place? Yeah, I think so. Well, yeah, those aren't too bad. Okay, let's do this. I think we're at a good place. Yeah. One little thing I've got to talk about is, so those are the chips. You guys are going to get to play with the chips here in a minute. Additive inverse. I want to come back to this. Because before today, I haven't been able to say this. Yeah, I got blue. So if I have 7, what is the additive inverse of 7? What's the opposite of 7 additively? Yeah, kick ass. We already know the multiplicative inverse would be 1/7. That's the number that I multiply to make it become the identity, which is 1. Additive inverse is the number I add to make it become the additive identity, which is 0. So I add -7. Yes. So if you see them say additive inverse, it really just means the opposite sum. So what is the additive inverse of -3/4? That's insane. Okay, and then what was your other idea, Jeff? Oh, dadgummit. If I come back to this problem we did a second ago, if I use a measurement model, does anyone remember what it means when I say I'm going to use a measurement model? What does that automatically mean? Number line, kick ass. And then the measurement model, when I was talking about multiplication, became this kind of like this grid, this array, the ice cube approach. Remember that? Okay, so that's like when it becomes multiplication. Right now we're talking about addition, so it's just going to be a number line. If I needed to do 1 minus 3, where do I start? Jeff, what have you done? It's okay, dude. Just do this. I start at 1, and I go back 3. Yes. Okay. So let measurement model be crazy nice. Now that we allow them to realize, oh, there's a whole other side of the number line. Now moving around works the exact same way. When I'm subtracting positive numbers, 5 minus 2, we start at 5 and we go back 2. Same thing now. Cool. And then one last thing. It's a little unfortunate that nobody has to balance a checkbook anymore. In fact, you guys might even know what I mean when I say that. You mean balance it on your nose? No. But if I had to do something like, if I had to do this, kind of a quicker way to do this is to put all your negatives together, or to realize, so there's 2 ways. I could put all my negatives together, put all my positives together, and then put those together, yes? Or, if you kind of go through, do you see something that kills 10? These two, so these 2 kill that. You guys see that? Yes? What about 11? Yeah, these 2 kill that. Yes? And what do I have left? 2 and 1. Yay! You guys follow? Why am I allowed to do that? Because addition and subtraction are on the same level of PEMDAS. Alright, I think I can shut up now. Let me see. How many people did I end up with? 3, 6, 9, 12, 13. Lucky number 13. Okay, let me think. Oh, math boy, you gotta do some math. Yeah, that'll work. Aw, I gotta lose you. That's too bad. Okay, I think that'll work.
Thank you. Wait.
Alright guys, let's see. I'm gonna be Team Snoopy. Where are my way too excited pumpkin little pie slices? I got Lily, I forgot your name already. Can you guys, let's see, there's plenty to remember. Who else is a pumpkin pie? Yes. Can you guys, wherever you like to be. You wanna be back there by Lily? I think she's got room. So everybody go over there. Not everybody. My pumpkin pie slices. Go with Lily. She's right there. Raise your hand. See her? There she is. Okay. Where are my pumpkins that have not been made into bread or pie yet? All right, got Grace, got Ella, and you guys, I right here in the middle. Everybody in the middle with Ella. I got my cats that have transitioned from Halloween to Thanksgiving. Okay, so I got Drew. I got okay. Enoch, can you guys come up here? And then, I think it's everybody? Is that everybody? Oh wait, I missed my turkeys. Sorry. Where are my turkeys at? I got one more turkey somewhere. Oh, there. So you guys just meet somewhere in the middle here if you want to. Okay. Here are these. So when you get that problem, just come up and grab a handful of both. Okay. And let me know if your group needs some help. And I'll tell you this. As soon as I'm done going over this, we're going to head out.
Yay!
I know. A little Thanksgiving miracle.
Yay!
All right. So I'll be a turkey. Why not? So guys, I propagated this throughout. So some of you guys have this somewhere else. I don't care. So I'm going to do this as they come. So everybody's got all of these problems, just in different order. A and B are negative is negative A plus negative B negative. So the example I was given some groups was, if I have negative 3, what's negative 3? What's negative 3?
3. No.
3.
Yeah.
Right? When I multiply by a negative, and here's one way to think about it. Got it. If I multiply a number by a negative, I switch the side of 0 it's on. So then what's negative 3? When I multiply by a negative, I switch the side of 0 it's on, so what's negative 3? 3. And we all know that when you multiply two negatives, it becomes a positive, but this is why. Yes? No?
Yes.
So another way to look at negative something is the opposite of this. So if this number is negative, it becomes positive. This number is positive, it becomes negative. Yes, it just makes it the opposite of what it was. So A is negative. Yes? So what is negative A? What's the opposite of A? This is positive. And what's the opposite of B? And what's positive plus positive?
Positive.
Yeah. Right? Now, the trick is your brain sees negative A and your brain says, well, that's negative, but we don't know what the shit A is. And I tell you here, oh, A is negative. So negative A is the opposite of a negative number. It's positive. So if I just wrote down negative X, is that negative? Your answer should be, I don't know. Because if X is positive, negative X is negative. If X is negative, negative X is positive. Are you guys with me? Okay.
Yes, yeah.
You're all in the same room. Okay. Additive inverse is just a different sign. Multiplicative inverse is another name for
Reciprocal.
reciprocal. So what's the additive inverse? Just change the sign so it becomes
-3/7.
-3/7. What's the multiplicative?
So 3.
Okay.
Yeah. No, we're gonna stay on me.
I was gonna say.
All right. And then 3A, B, C are really just, do you remember how negatives go with PEMDAS and all this stuff? What do you have to do first in 3A? Parentheses. Now, this kind of problem, I'm asking you to use everything you already know. So you already know what minus and negative is. You with me? So I'm doing in the parentheses first. In the parentheses, I would do minus and negative is plus. And what's negative 8 plus 3?
5.
-5.
Negative 5. And then we use the same thing again, right?
1 plus 5.
Minus and negative is plus 6. Okay. Who's got a way to do part? Obviously, number 3 would be not in your calculator because I'm not here to test if you can push buttons. How would you do this by hand?
Round to 29
Round
to
it.
30.
Oh yes, you can do equal addition. So the first thing I would do is to go, sort of like you were telling me earlier, this is equivalent to 2 steps. What is this?
Very good.
And then
Just throw a negative sign.
change the sign, right? So you're telling me, which is a beautiful thing, I'm gonna use equal additions to make this 152 minus 30. That's much better, right? And what do you get there? 122, and then the answer to this then would be negative 122. Do you guys see that? When I'm combining 2 numbers, if the numbers have different signs, I subtract them, and then I put the sign of the bigger one on. That's the most straightforward way to say how to put together 2 signed numbers. This is an example like we did earlier. You can kind of do this. Does negative 3 cancel with anybody?
Yep, the positive 3.
Yeah.
And the 5.
What else cancels? The 5 and the negative 5 and the 6 and the negative 6, so the answer is 8. Yeah. And you're allowed to do that because PEMDAS. I have addition and subtraction, you can do them whatever order you want to. That's it. And then, oh yeah, that's right, we did this one. Okay. So sticking to my word, this is the earliest I think we've ever left, and I'm cool with it. I'm just happy you guys came. So your little gift today is to get out of here early.
Yay.
So next we'll obviously, hopefully this is obvious, next week don't come. We have the entire week off. Yes. So I'll see you again on Monday.
We have a quiz.
Tuesday, sorry.
We have a quiz.
Oh, I'm not seeing Monday. No
Yay.
quiz yet. Probably, maybe Thursday. I'll think about it. We'll come back. I haven't really thought about it.
Okay, so wait, the final is just like everything?
Final is cumulative. Yes, and I'm gonna have a practice final, just like every other test. Did you get all the chips from everybody?
Hey, so you get to leave early now.
Not shuckles.
All right, guys. Thank you for coming.